biological age clocks are just accelerating. I mean, it's extraordinary. Even from our study, which was published in 2021, there's second and even third generation clocks now. There's a clock called the Grim Age that is aptly titled, it predicts time till death. So yeah, you want that as young as possible. But indeed, I think that you're correct. We're going to be getting those numbers from our doctors, and eventually I think we'll be able to access them ourselves. I mean, ideally in some future time, this is my Aura ring, I'll be getting my BioAge data right here. And I'll be able to tell, what activities, events, my sleep, et cetera, all of the input that goes into this now, is it, pushing biological age fast, or is it slowing it down?
The idea that there's a test called a grim age that can tell, I mean, essentially, probably, I imagine, with some predictive accuracy, how long you
Yes.
have until your death. That
Yeah.
sounds pretty remarkable.
Or time till illness. There's
Yeah.
another clock called PhenoAge, which looks at morbidity and mortality as well, but how your good years left. Yeah, it's
I,
getting very,
yeah.
and there's even a rate of aging clock that I actually like quite a bit, called the pace of aging, which, if you're greater than one, you're aging faster than chronological age. So we all want to be less than one. And this one is very responsive to different interventions as well. And so it's something that we could test repeatedly, and make sure we're living our best lives. Unfortunately, it's kind of still cost prohibitive to access these clocks, but I'll say, just from the time in our study, the clock that we used, or the test that we used, was in the research setting only. No, that's no longer the case. And back then in 2018, 2019, it was $1,200 per. It was very expensive. They're down to maybe $200 now. So expect these numbers to continue to drop and for them to become more and more available to us.
Someone is listening to this conversation, they going, wow, I mean, how can there be a test that tells me what my biological age is? How can there be a test that tells me, what my rate of aging is, as
Yeah.
opposed to, just birthday to birthday? And even the craziest one, how can there be a test called the grim age that tells me perhaps, how long it is until I get seriously sick or even die? Could you
I
explain, like,
know.
kind of the biology in that?
Sure. Yeah, that's such a good question. It's a great question. So we're looking at gene expression. This is the era of looking at what genes are on and what genes are off. It's called epigenetics, epi above, genetics, your genes. So uh, patterns of gene expression, and specifically, so when we're in epigenetics, there are a number of variables that regulate gene expression. Epigenetic marks, they're called, a number of different biochemical marks that influence what genes are on and which genes are off. But the most studied and one of the most resilient and arguably the most important ways that we turn genes on and off is something called DNA methylation. And the clocks are based on different patterns of DNA methylation. The original clocks, the earliest clocks, were trained against chronological age. And so basically you can just think about a massive, massive data set of DNA methylation marks of thousands and thousands of people were, just fed into this big computer, with the question being, what pattern of DNA methylation marks correlates most strongly with chronological age? So these were the first clocks, and actually the clock that we used, the Horvath multi-tissue clock, which was the only clock available in 2018, which was like yesterday. It's kind of crazy how fast this technology
Right,
is
right.
moving. Um, so Steve Horvath, who developed this clock out of UCLA, University of California in LA, asked, basically, what pattern of DNA methylation marks can most closely predict chronological age? And he was able to do it with almost complete accuracy, 0.96. So very, very tight.
Oh,
So they looked in utero, so they looked at fetal DNA all the way to, centenarians, and they were able to predict across the timeline different changes. And there were just 353 methylation marks. They're referred to as CPG sites because on the DNA, it's on a cytosine when the cytosine is next to a guanine and it's connected by a phosphate. That's the piece. So CPG, they refer to them as CPGs. So in the Horvath, the first Horvath clock, which is what we used, there are 353 sites, and it's very predictive, very close to chronological age, except it's actually not perfect. There's that little bit of wiggle room, right? That 0.4 because it's 0.96. And what they demonstrated is that these DNA methylation patterns, even in this first clock, were more predictive of morbidity and mortality than chronological age. So even at the very first iteration of the clocks, they were better predictors of health outcome and lifespan. Isn't that amazing?